We move on to problem solving with rational expressions. So things we have to know is or are how to simplify rational expressions, solving rational expressions. But when we have a word problem or a problem in real life, before we get to those two steps, we have to understand the problem, translate the problem, to or in mathematical terms, there we go. And once we get that part, we go to simplify the expression and solving the expression so that we get solution to the real world problem. So let's start with an example where we want to solve the following equation: 1 over r equals 1 over r1 plus 1 over r2, but we want to solve it for r1. So we have two terms on the right hand side. Let us combine it so we get a common denominator. There is nothing in common between r1 and r2, so the least common denominator would be r1 times r2. So the right hand side is 1 over r1 plus 1 over r2. I want to make the denominators alike, so I'm going to multiply and divide the first fraction by r2 and the second fraction by r1, which would give me r2 divided by r1 r2 plus r1 divided by r1 r2. Now I have a common denominator, which is r1 r2, so I can combine the numerators, giving r1 plus r2 divided by r1 r2. So I have the left hand side, which is 1 over r. Right hand side, I rewrote it as r1 plus r2 divided by r1 r2. So we have one term on the left hand side, one term on the right hand side, so we could cross multiply, which would mean r1 r2 is equal to r1 plus r2 times r. We want to solve for r1, so r1 r2 would equal to r times r1 plus r times r2. Move all terms containing r1 to one side, so r1 times r2 minus r times r1 equals r times r2 minus r2. We have r1 in common here, so if I pull r1 out, I would have r2 minus r. We have r2 in common here, so if I pull r2 out, I would have r minus 1. So we have to solve for r1, so I'm going to divide by r2 minus r on both sides. So those two terms would go away, which would give me r1 equals r2 times r minus 1 divided by r2 minus r. So here is a word problem. So a 170-pound person weighs approximately 65 pounds on Mars. How much does a 9,000-pound satellite weigh? So we could convert this to a person's weight on Earth divided by the person's weight to the satellite's weight on Earth equal to the person's weight on Mars divided by the satellite's weight on Mars. So person's weight on Earth is 170 pounds. The weight of the satellite is 9,000. The person's weight on Mars, 65. We want to find the satellite's weight, which is x, we do not know. So we could rewrite this, since we have one term on the left-hand side, one term on the right-hand side, we could cross-multiply. Yielding x times 170 equals 65 times 9,000. X would equal to 65 times 9,000 divided by 170. So the zeros would go away, and 17 goes into, let's do it a different way here. 17 does not divide 65, so keep it as is, which would give us 65 times 900 divided by 17. We can make use of a calculator to find this answer, and that would give us about 3,441.76 pounds. So a different way to approach this problem, perhaps I'd put it as a side note. So a person's weight on Earth a person's weight on Mars is some proportion p times the weight on Earth. So we want to solve for that p. We know if a person weighs 170 pounds on Earth, then it is 65 pounds on Mars. So the value of p is 65 over 170. So we would have 0.38235. 3. So if that is the case, the satellite's weight on Mars would simply be equal to p times the satellite's weight on Earth. So we multiplied 0.38235 times 9,000. And you should get the exact same answer. That is the reasoning behind it. It doesn't matter whether you take that approach or this approach. It is entirely up to you. So here is another example where we have an experienced roofer who can roof a house in 26 hours. So time taken by an experienced roofer is 26 hours. The time required by a beginner is 39 hours. So what would it take if they work together? So to complete one job, the time it requires for a roofer let's say it is T hours. So this would imply 1 hour of labor would equal to 1 over T of the job. So if the job takes 30 hours and the person can do it in a time T, so that person would require the job time divided by T. So I could write it as time required to be equal to 1 over T times the job time. So in other words, let's say a job requires 260 hours. This would imply the experienced person can complete the job in 260 hours divided by 26 hours, which would be 10 hours. So here, the experienced person and the beginner person put their efforts together to complete it in some time. So we'll call it 1 over T. 1 is the job and T is the unknown time when we combine the two. So the experienced person would complete one job in a matter of 26 hours. So 26, the beginner would complete one job in 39 hours. So those two would equal 1 over T. We have two terms on the left-hand side, so we need to find the common denominator. There is nothing in common between those two terms, so I'll take that back. So we could write 26 as 1 times 2 times 13. We could write 39 as 1 times 3 times 13. So the LCD is, we have 1 in common, 13 in common, the 2 and 3 are left behind, so we just write them down. So that would give us 78. So we want to convert the denominators here into their LCDs. So 1 over 26 times 3 over 3 plus 1 over 39 times 2 over 2 would equal 1 over T. So 26 times 3 is 78, so 3 over 78. 39, 2 is 78 also, so 2 over 78 equals 1 over T. We have a common denominator now, which is 78. We combine the numerators, 3 plus 2 equals 1 over T, which would imply 5 over 78 equals 1 over T. We have a single term on the left-hand side, single term on the right-hand side, so we could cross-multiply now. So cross-multiply, T times 5 would equal 1 times 78. T is 78 over 5, which is 15.6 hours. So we want to solve problems involving distance, rate, and time. Rate is the same as velocity. So rate is the distance one covers over a period of time. I'll call that D, I'll call that T, I'll call that V. If I rewrite it, V is simply D over T. D is V times T. So let us not forget that expression. It's quite important. So the speed of lazy river's current is 5 miles per hour. A boat travels 20 miles downstream in the same time as traveling 10 times upstream. We have to find the speed of the boat in still water. So we know the speed of the current. And the downstream distance is 20 miles covered. The distance upstream is 10 miles. And what we know is the rate of that boat is they are the same. So we'll call it D down. And that would be D up. So we know the speed of the current, the lake's current, and we want to find the speed of the boat. So in other words, we have to find the time upstream and time downstream. Time is simply the speed divided by the distance. So I'm going back to that expression. Time is distance divided by the velocity, or velocity is distance divided by time. So the speed is going to be the same. So speed divided by the distance. So while the boat is going upstream, we have a push of 5 miles per hour. So the speed of the boat is going to be increased by 5 miles or decreased by 5 miles upstream. The distance is 20 miles. The speed downstream would be increased by 5. And I'll call R to be, or I called it V, so V and V plus 5, and that distance would be 10. Now, why is this the case? So if the current is 5 miles per hour, and let's say the boat speed is V miles per hour, then as the boat is going downstream at v miles per hour, it is going to get a push by 5 miles per hour because the current is favoring the boat downstream. So the velocity of the boat would be 5 plus v miles per hour. In other words, it is pushing the boat to go faster. But if the current is 5 miles per hour and the boat is going upstream at v miles per hour, the current is against the boat's speed, so it is going to decrease the boat speed by 5 miles per hour. And that is how I get the v minus 5 and v plus 5 there. Now, since the time is the same, it's 20 miles downstream and 10 miles upstream. I have this backwards. 10 and 20, I apologize. So the time would be the same. So we would have time upstream equals time downstream. And we have that relationship as v minus 5 over 10 equals v plus 5 over 10. The velocity of the boat, v, is reduced by 5 miles because the boat is going against the current here. And there it is going in the direction of the current. So the velocity increases by 5 miles. So we have a single term on the left-hand side, single term on the right-hand side, so we can directly cross-multiply. So v minus 5 times 20 equals v plus 5 times 10. So 20v minus 100 equals 10v plus 50. Move all the v terms to one side and the numbers to the other. 20v minus 10v equals 50 plus 100, which would imply 10v equals 150. So v would be 150 over 10. This would mean v is 10. Bad algebra. 15 miles per hour. So the speed of the boat is 15 miles per hour, and that is what we would have.